So now that we talked about the AND variant of the two-stage completion stage methods that wait for both things to finish, obviously the other way of waiting for things is to wait for either of the two previous stages to finish, and that's the OR variant. And so in this case, we're going to take a look at a method called except either. And this particular method is triggered by the completion of either of the two previous stages. So it's kind of like the matrix. You get a choice. You pick one. You pick the red pill. You pick the blue pill. Does everybody remember which pill you pick if you want to get out of the matrix? The red pill. So never forget that. The next Matrix, next movie in the Matrix franchise is coming out in a couple months. So I saw the trailer when I saw some of the recent Marvel comic movies, and it looks really good. The special effects are out of this world. They were always pretty cool, but now they're really cool. So except either, as you can see here, is going to have an action that runs when either of the two previous stage results are done. And so this is basically logical disjunction. And as with the AND version, the one that like then combine, there's a completable future that's used to invoke except either, which is the this version, the this object. And then there's the other future, the other completable future that's passed as the first parameter to except either. So those are the two that we're dealing with here. It returns a completable future to void. You would often use this at the end of a completion stage. And I'm going to show you an example. This is another example of how we can take advantage of all these different proliferation of cores in a modern multi-core processor. So once again, theorists like to argue which sorting algorithm is the best. What we're going to see here is it no longer matters because you can pick your favorite two sorting algorithms. You could use quicksort and merge sort, or heap sort and quicksort, or heap sort and merge sort, or insertion sort and quicksort, whatever you want to pick. Pick two of them, have them go off and quicksort a list in parallel. So you can see here that we go ahead and say completable future supply is synced with quicksort of a list. Completable future supply is synced with merge sort on the list. They both get back completable futures to lists of sorted big fractions. And then we do the magic with except either, and we basically say, whichever one finishes first, we're going to take those results and we're going to go ahead and print them out in sorted order. So this basically says, if quicksort future finishes first, take the results of the quicksort. If merge sort completable future finishes first, take the results of the merge sort. You don't really care. You just want whichever one gets done first. And then down here, we take the results, which is this list. And for each element in the list, we go ahead and print out the element as a mixed string. So this is a great way of circumventing, 20 to 50 years of theoretical analysis of the asymptotic time complexity of different sorting algorithms by just running a bunch of them in parallel and picking the one that finishes first. And we'll see that there's actually ways to generalize this to many. So if you're not happy with two, if you want to do all 20 sort algorithms, you can do that too. That just requires a slightly different method called any of. And we'll see that when we talk about arbitrary arity methods. Note, curiously enough, that whichever completable future finishes first, that's the result that's used. But the one that's still computing, the one that hasn't finished first, the one that finishes second, is not canceled. It continues to run until it's complete. And there's a reason for that. And the reason is that that completable future could be needed for something else. And it's perfectly okay to use these completable futures in multiple contexts. So it doesn't unilaterally cancel it. Now, you could decide to cancel it if you wanted to, but it doesn't get canceled unilaterally when the first one finishes. Okay, so that's the end of our discussion about the two-stage completion stage methods. As you can see, one variant, which we talked about in part one of the video, handled the AND, where they both have to complete. As we see in this video, we can wait for the first of two to complete. And then as we'll see as we get a little further along next time, that there's also these other methods that are generalizations of this. So there's a method called all of, where you can give it sort of an arbitrary sized array of completable futures, and it'll wait for them all to be done, and then it'll return a completable future that waits for them all to be done, and then it'll complete. And there's also the any of arbitrary arity method that will take an arbitrary sized array of parameters, and whichever one finishes first, that's the value that's used to complete the results. Okay, any Any questions about any of that stuff? Lots and lots and lots of cool things. For those of you who came